大家下午好，欢迎大家来到谷歌的网络技术讲座系列。在这一讲里面，来自法国的 Patrick 将给大家讲述 HTML5 的技术，将会通过一些简短的这个代码和一些有意思的 demo， 给大家讲述在未来的发展方向里面 HTML5 可能发挥什么样的作用。下面有请 Patrick。
Thank you, Xiao Hao. That's kind of the extent of my Chinese for today. I'm French. So my name is Patrick Chanezon. I'm a developer advocate with Google, and I manage the team that does developer advocacy for HTML5 and open web technologies. So today we're going to talk about HTML5 and SVG and open web technologies and the work that Google is doing in this area. I'm pretty sure you've seen the keynote. I'm going to go in more details about all the technologies that are available in modern browsers today to create rich web applications. Before I start, I'd like to know who among you have developed some applications that involve Flash, the Flash plugin. Yeah, just a few of you. That's good. Yeah, because with HTML5 you don't need Flash to create rich applications. So the browser started a revolution that continue, and I was kind of lucky to be at the first stage of that revolution. I used to work with Netscape, and in 1995 Netscape introduced a language called JavaScript in the browser. Initially it was for developers to just create little make their application a little bit richer. The capabilities were really reduced, but it really took off. People started building lots of things with JavaScript. In 1999, it became much more interesting when Microsoft introduced something called XML HTTP request. And XML HTTP request allowed you to have your web page, make some calls to the server, and get back some data, and then refresh the DOM of the page without having to refresh the page for each interaction you want to do in the web page. So what XML HTTP request allowed is what we call later AJAX applications. These applications that really look like a desktop application, you always stay on the same page, but the page just adapts to the application, like the kind of experience you would have in a desktop app. In 2002, Mozilla included XML HTTP requests natively, and that's when AJAX starting to take off. One of the first big AJAX application was Gmail. So when Google launched Gmail, developers started to realize, hey, we can really create these rich applications using web technologies as opposed to building native apps. And then around 2005, AJAX started to take off, and you saw more and more of these rich applications out there. Google Maps is a good example. Nowadays, if we switch 4 years later, you see lots of these AJAX applications. And today, we are moving to, with HTML5, we are moving to the next step of evolution of the web client. So what kind of new capabilities do web apps need if they want to compete with the native apps? Initially, all the additional capabilities that were needed by web apps were managed by plugins like Adobe Flash. So the capabilities you need are playing video. YouTube is a very good example. Webcam and Microsoft access to the microphone to be able to register some videos or audio. Better file uploads. I'm pretty sure many of you have coded some application where you had to do file uploads. It's really painful. Geolocation, offline abilities. You want your app to work even when there's no network. 3D, positional and multi-channel audio, and drag and drop of files from the desktop into the web app. The good news is that many of these capabilities are moving through the standards process in the HTML5 working group, And so now many of these abilities are already as part of the spec, and the good news is that many of them are already implemented in most modern browsers. So the goal of Google is to empower web applications. At Google, we bet on web application, on the web application model of development, and we want web application to be able to be as rich as regular desktop applications. So our goal is to build these capabilities in the browsers through open standardizations of many of these aspects. So we need to figure out what kind of native application do people run, and how can we build these web applications that serve the same purpose. In terms of implementation, we took a very pragmatic approach. What we did is that Google created a product called Google Gears a few years ago, and the goal of Gears was to prototype these abilities that we need in modern browsers. And then we worked with the WG group to standardize these abilities in HTML5. So for example, in Gears, 2 years ago, you already had the ability to create an offline application, to have geolocation API, and a more powerful file upload. Right now, all these have been moved into the HTML5 specification and are implemented in many browsers like Chrome, Firefox, Safari, or Opera. So I may not speak Chinese, but I'm a big fan of Chinese poetry, and so this is a quote from Chuang Tzu. He said it's the famous poem where he says whether he's not sure whether he's dreaming he was a butterfly or whether he's a butterfly dreaming he's a man. And for me, that quote really illustrates the conundrum where we are today with web applications, where we don't know whether, when we need to build something, whether we should build a desktop application that has some web feature, or whether the features of web applications are good enough so that we can start building all these rich applications as web applications. And today, the web model is moving to a client-server model. When I started working 15 years ago in software, I used to be building client-server applications where you had a rich client talking to a server that hosted the database, and the rich client had offline capabilities, a local cache for data, and then it was synchronizing with the server. 10 years later, we started to have, in '95, we had the web model that started to take off, and the initial web applications were really like the mainframe model from the 60s, where the client had no smarts at all, and all the smarts and the algorithm were done on the server side. So your client was like a VT100, where it would just request for each interaction a page from the server. Right now, with the new capabilities in HTML5, the client has some graphics capabilities, offline capabilities. It can synchronize with the cloud and offer you an offline application with some rich UI. So this comes back to Chuang Tzu's dilemma about the butterfly and the man. I think applications are just starting to become very nice. Web applications are starting to become very nice butterflies. So when you want to do vector graphics, for example, today, this is what the market share looks like. So you have Flash that has 99% market share, and then you have Silverlight from Microsoft that has 20% penetration. And these two are both proprietary technology that are controlled by one company. On the other side, you have specifications like SVG from the W3C, and HTML5 from the WG working group. HTML5 includes an element called Canvas that lets you do 2D vector graphics. Both of these have a penetration of 33% in browsers today. And at Google, for both SVG and Canvas, we're building some JavaScript shims that allow you to use them in IE. And both of them are using Flash or VML to make that possible. So Canvas. Canvas was one of the first HTML5 additions. It came from Apple. Apple initially built Canvas to build their widgets on the Mac platform. And the Mozilla guys liked Canvas very much, so they implemented it as well. And they pushed that through the WebWG working group so that it's part of HTML5 to be standardized. Canvas provides you a surface on which you can draw 2D images. So this is an example of using Canvas. Essentially, you just define a Canvas tag in your page, you give it an ID, and here I'm doing a get context on that Canvas element. And then I can start drawing. So here I'm drawing a rectangle, I'm setting some attributes, I'm filling the rectangle, I can get the width for the canvas and fill another rectangle. So open web vector graphics are available in a browser near you. What that means is that today they are implemented in Firefox, Safari, Opera, and Chrome. What's more interesting is that if you're building web apps that you want mobile users to use, mobile users who have recent mobile phones using either an iPhone or an Android phones, both iPhone and Android support Canvas, and iPhone supports SVG as well, and it's in the works for Android. So if you look at this table, you can see that apart from Internet Explorer, all the modern browsers support these technologies, and we're working on these open source shim layers that essentially allows you to say, oh, I'm just sourcing a script, that's the shim layer, and once you have sourced it, you can start using Canvas or SVG, and the shim layer is going to translate these Canvas or SVG instructions into either Flash for rendering or VML. So how to use Canvas? When you draw in Canvas, you have a grid that looks like this with the X and Y axis. That's how you specify the coordinates. And then you can start drawing shapes. So here I define a fill style, that's how my shape is going to be filled. And a stroke style is what will be around my shape, the contour of the shape, how it will be filled. You can specify the line width, and here we're just drawing a bunch of rectangles with different styles. In addition to shapes, you can draw path. So this is an example of drawing a path. A path essentially is just moving the canvas context from one point to another with a specific fill style, stroke style, line width. And then when you're finished with your path, you can close it with the close path instructions. You also have access to arcs and curves. So an arc is drawn specifying the center, X and Y, the radius, and the start and end angle, and which trigonometric direction you're going, whether clockwise or anti-clockwise. So these are some examples of arcs. You can also draw some quadratic curves or Bezier curves. I recommend Bezier curves because quadratic are broken in Firefox 3.5. These curves allow you to specify a few control points. So there are 3 of them for a quadratic curve and 4 of them for a Bezier curve. These are typically the concept that you find in 2D vector graphics drawing applications like Adobe Illustrator. You can specify styles and colors in many different ways. So you can use either CSS colors like this, or you can use HTML colors like that. Or you can specify the RGB values or the RGBA values. So that means red, green, blue, and the alpha channel for transparency. You can also specify a bunch of attributes for your lines, what their style is, what their cap looks like, the joints, and the meter. You can create gradients, so there are linear and radial gradients, and you can add stop colors to these gradients, and you can even create patterns. Where Canvas is really interesting compared to other previous web technologies is that it allows you, it gives you direct access to images, and you can do pixel manipulation on these images. So this is an example where we have this image there, and we're just going to draw this image in the canvas. So we do a document get element by ID of the source. So the source will be this image tag. And there we're going to draw it in the canvas. And you can, so you can slice this image. So here what we're doing is that we're taking just a small slice of it. And then we take the image for the frame, which has a transparent background here, and we draw it just above the other one. And so the result is like this. Now, pixel manipulation. I'm going to show you an example that's quite similar to the one that was shown this morning during the keynote. I'm going to show you the code of how this is done. First time I saw that example, I just couldn't believe that you could do that in browsers today. So this example was made by Paul Rouget from Mozilla. He did lots of very creative examples, mixing and matching these technologies. So this is using the video tag that I'm going to talk about later. Video tag allows you to embed a video, and the player is the browser. You don't need any plugin there. So here, when I'm playing the video...
Ok, alors attends, ça c'est bon.
So,
Non, ça enregistre là. C'est juste pour voir, je prends des trucs n'importe quoi, hein, c'est normal.
So here what you can see is...
Vas-y.
It's something called chroma keying, and it's done in real time on the client side. So what chroma keying is what weathermen are using on TV, for example. The weatherman is just shot in video in front of a green background, and then there's some video processing machine that removes the green background and gives you the weather map as a background. So here what happens in this demo is that Tristan was just shot against a green background, and then in real time, on the client side, in JavaScript, the developer is just playing the video, and then in an infinite loop, he's pulling images one by one from the video, and then for each image, he just looks at all the pixels in the image. He puts this image in a canvas that's here, takes all the pixels from the image, processes them. If it's green, he just removes them, so it becomes transparent. And then with the resulting image, he pastes it into this canvas that has a different background. And so the result is that in real time, you have chroma keying. And with the fast JavaScript VM that are in browsers today, this kind of processing is possible. Let's take a look at the source code for that. Okay, so here we see the source. It's very simple. We define, in a div, we define a video element, a video tag. The source is a Ogg Vorbis file. So today in Mozilla, the video tag supports the Theora encoding, which is an open source codec. In Chrome, we're working to support H.264. We say controls equal true. That means we don't have to create our own controls to play the video and stop it. These controls will be provided by the implementation in the browser. And then we define two canvases, C1 and C2. That's it. All the rest of the code is in main.js. So let's go in there. What do we do in there? So on doLoad, we have this function that sets up a few variables. So in this object, we set a video element. We just do a document get element by ID for the video element. Same thing for C1, which is the first canvas, and then we get the 2D context for it. Same thing for the C2. So we have these two canvas contexts that are ready for processing. And then we say, on this video, we're going to add an event listener on play. And on play, I want this function to be applied. And what does this function say? It just sets the width and height to half of the video, because in order to have smaller images to process. And then it sets, it calls timer callback. And timer callback is a function here. In this function, what we do is that if the video is paused or ended, we return. That means we exit. So this function will stop when the video stops. And then we just compute a frame. And then with the set timeout, with a timeout of 0, we call callback recursively. So what this means is that this function will be called recursively until the video stops. And what will happen is that for each image, there will be we will call our compute frame function. And the video processing code is here. It's very short. Here what we do is that we, so we're, from the context1 canvas, we just draw an image there. And draw image can take as a parameter a reference to an image element in the document, but it can also take as a parameter a reference to a video element. And when you give it a reference to a video element, the result is that the current frame in the video is just extracted and put in the canvas. So we put this, the current frame of the video in the current canvas, and then thanks to the function, the canvas function getImageData, we're getting an array of data for each pixels in the image. So we get that in the frame variable. And then after that, we just loop until 1/4 of the data length of the frame. And then we just extract the RGB values of the pixels, of each pixel in the frame. And then we check whether the pixel is green. If it's green, we set it to 0. Once we're finished with that, our frame array is full of the same bits as the original bits for the image, except for the ones that were green that we have replaced with transparent. And then what we do is that we just put this image data that are in this frame array, we put it in context2, and context2 has a different background. So Tristan's image is just displayed in front of a Mozilla background. So that's all there is to it. It's very short code. And the demo you saw this morning went a little bit further, doing image detection. Talking about which, so Paul has made many other examples of this one. Just add subtitles. So you can switch the subtitles from one language to the other. He made some other pretty cool demos. Let me see if I can find them. Oh yeah, this one was amazing. So this one was pretty much in the same line as the one that you saw this morning. In here, he uses like many of the technologies available in HTML5. So he's using a video tag to play the video, and then he's using a canvas to analyze the image, and he uses worker threads to analyze several images one after the other.
Je te dis quand t'arrêter.
So here you see someone coming into the frame, and then he analyzes the difference between two images, and when he sees the difference, he outlines the shape of where the movement happens.
Stop.
And then he draws this shape using a separate worker to say this is where there are some movements in there. So the video, the demo you saw this morning is very similar to this one. Other interesting use of Canvas, these examples that I showed you are kind of technical demos, not really real applications. There are some real applications out there on big websites that use Canvas. And this is an example, it's called Yahoo Pipes. So Yahoo Pipes is an application designed by Yahoo to let you filter your feeds. So you can assemble 3 or 4 feeds and then filter them by author and gather them together. So in this example, in the open web advocacy team at Google, all of us blog on different platforms. I blog on my own blog on WordPress, and when I blog about open web, I have a specific tag. My friends are blogging on the WhatWG group, another one on the Ajax blog. So I just created this pipe that fetches all these feeds and then filter them, so you can create filters here. So if the DC creator is Brad Neuberg, then I just take this post, and then I do a union of all these feeds together. The thing is, this UI, to create the filters, is drag and drop. So I can say, oh, I want to fetch a new feed. So I'm just going to add this. And I'm going to specify a URL, and then I can say, oh, I want to add this to there. All these little joints between the various boxes that can move when you move the boxes around, they are drawn using Canvas. And the Yahoo engineers who have built that did a very good explanation of the techniques they used to do that and why they chose to use Canvas on the Google Code blog. So you can find more details about how this one works. This is another example that I can't resist to show you. This one is it's a tutorial about how to learn Canvas. So bit by bit, the tutorial teaches you how to run, how to create this this brick breaker Canvas application. So this is all drawn using Canvas, and my son is 7-year-old and he's starting to learn programming. So the other day I started teaching him JavaScript and Canvas, and so we took that as an example. We did the tutorial together, and then he wanted to modify it because he's a real Star Wars fan. So I showed him how it's easy to just modify an existing JavaScript program and customize it to his needs. So that's the code he wrote, or how he customized it. Let's see if it still works. Oops. Whoa. I'm not sure it still works. Yeah, so essentially what we did in there is that we replaced some of the URLs that are used for the colors and all this by Star Wars theme. But the URL don't seem to be available here. Yeah, so I won't be able to show you that. Yeah, I need to publish that on my blog. Another very impressive use of Canvas I've seen out there is the Bspin project by Mozilla. So Mozilla is building this online editor that's collaborative, where you can collaborate with others to edit your code. And the whole editor is coded in Canvas. So here's an example. I'm just going to go to the sample project, and I'm going to edit some JavaScript. And let's take what they have in there and replace it with my son's code. So you can see that they have a syntax coloring in there. It's pretty responsive. And it's a very good editor to edit HTML and JavaScript. Right now they're adding binding to subversion, source code control, management, and things like that. This project is open source. So you can look at the source, and it's a great example of Canvas use. They are making very heavy use of Canvas in there. Same thing, Dion Almer and Ben Galbraith from Mozilla, who built this application. They wrote a very good explanation of why they used it on the Google Code blog. So you can find it over there. Okay, what kind of other cool demos did I want to show you? Too bad this one doesn't work from here. It's Blogspot. So these ones were, yeah. So there are some Japanese guys who essentially, when you can do triangles and manipulate color, you can do 3D. And so what these guys have built is a 3D rendering using Canvas. There's a more basic Raycaster example that you can find here. Where is their live demo? Yeah. I think this one was showed this morning. Yeah, so you can go into a landscape, and it's a labyrinth, and this is all drawn using Canvas. The Japanese demos are more impressive because they do texture mapping and reflection. I should have saved it before coming here. So let's go back to our presentation. Yeah, in Canvas you can also do transformation, so rotate, scaling. You can provide your own matrix with set transform. So this is an example of applying a transformation to rectangles. So here I just translate a rectangle and then I apply a fill style. I just have a loop to draw 12 shapes and I just rotate it. Yeah, so that's what the 3D example looks like when you look at it, and it's all coded in Canvas. Okay, so I showed you the Canvas demos. Now, in addition to 2D capabilities, HTML5 also has the notion of local storage. So essentially what you have is in the browser now there is a SQL-like database, and you can do some queries against it. You can create your own schema in it, and you can store data. So when your application is loading and you're connected, you connect to the cloud, to your server, you grab all the data, and then you store them locally. Then when the user is offline, they can use the application offline, and so your application is just going to the database instead of going to the cloud. And when your application connects again, then you need to reconcile what happens on the client and the server side. So you need to build your own replication protocol if you want. So the implementation is underway in Google Chrome, but it's already available in WebKit, which means in Safari, for example. Workers, I showed you a demo of that. So Workers allows you to do concurrent JavaScript. It's more like processes than threads. It allows you to have some code in JavaScript that runs in concurrent processes, and then they communicate through messages, through an API called postMessage. So if you have lots of computation to do, you just do it, offload it in Workers. And application cache goes with local storage. Local storage is useful for building offline web apps, but then when you're offline, you still need the assets of the application, like the HTML files, the images, the JavaScript files. So with the application cache, when the user loads your application for the first time, the browser accesses a manifest file where you define all the assets for your application. And when the browser sees that, it just gets all the assets, stores them locally, and so when you open the application and you're in offline mode, the browser is going to go to its local cache to serve all the assets. Video tag, I showed you a lot of demos working with that. So Chrome will support MP4, which means H.264 for the video encoding and AAC for the sound. And that's a that's a really good set of codecs that are quite well accepted in the industry. And it will support OGG, which is Theora and Vorbis. So Theora is for the video encoding, and Vorbis is for the sound encoding. Mozilla only supports OGG because MP4 has some patent issues, but is more widely adopted by content providers. So this is implemented in WebKit, and it's on its way in Google Chrome. So I showed you some video demos. Another area that needs some work, you saw the Bspin editor that I showed you. It's a big piece of code all written in Canvas when they're doing the rendering and the coloring of the syntax highlighting, all using Canvas. And you wouldn't need to build that code if HTML had a native rich text editing capabilities. So there are a bunch of rich text editors out there in JavaScript. Some of them are okay, but they vary, their capabilities vary depending on the browser in which they run. And so what we're trying to do is to have a content editable implementation that's better, to define a new specification to say, just give me a rich text area where I can do some pretty cool editing. And that should be part of the browser, essentially. Notification is another way, is another thing that's kind of broken today. So there are lots of JavaScript libraries out there that give you various solutions for notification. Right now, the Chrome team is prototyping some solutions, and they push it to the standards when they're happy with the solution. WebSockets is a very interesting project. The spec is under active development right now. What it allows is instead of doing XML HTTP requests where you just make a HTTP request to the server and get it back, WebSockets will allow for two-way communications. And this is a very much needed feature in browsers now that browsers are used for more and more real-time type of applications where you get real-time data. The way browsers do that today, or the way application developers implement that kind of feature today, is by polling. So they're polling the server all the time to see if there's some new stuff for them. So WebSocket would kind of solve that problem. And then 3D API. So Canvas 3D was developed by Mozilla. And it allows you to make OpenGL calls in JavaScript. And Google has a similar effort called O3D, which is a retain mode API where you can build a scene graph and manipulate it via JavaScript. So I can show you a demo of that. Maybe I haven't preloaded the demo. So today, O3D. So today, O3D works with works with a plugin that you can install in your browser. I have installed it into my Firefox browser here, and so let it load, and it's just using pure JavaScript to draw a 3D scene, and you can see the scene emerging here. I think he showed a demo this morning of that. I'm just going to show you the code that was that generates that scene. I'm going to let it load, and I'll go back to this. The goal of O3D is to just push it to the standards bodies to standardize a 3D API for web applications. That's a very important aspect. Okay, we're nearly there. Cool. Okay. Yeah, so when you look at the source for that stuff, it's essentially a few divs and then a bunch of JavaScript. So you see here, just setting some screen positions and then some vectors. So it's essentially a JavaScript API. So there's a whole API that's defined on there's a Google Code project for that, where you can find all these samples and you can get familiar with them and analyze them. What's nice about O3D is since it's JavaScript, you can just use Firebug to take a look at it. So let's say Firebug is enabled. I can take a look at the DOM that's been built. So I have a bunch of variables here, and I have some images. So essentially, to code that, you use the same tools that you would use to create a regular web applications. And if you look at the net console, I didn't activate it. But you can debug it the same way using the script debugging there. So beyond what I showed you, there's lots of areas where there's still some work to do in the, for standardization. So what's well defined today is geolocation, the forms, and the data grid. But there are some things that still need more definition, like some P2P APIs, better drag and drop support. Right now people are using jQuery or other libraries to implement drag and drop, and it should be better specified in the spec. Webcam and microphone access are things that are also really needed. The Flash plugin has that. And if you want to do some application that record videos from the user, you need that kind of capabilities. OS integration as well, where you can just drop an image or a file from your desktop into the browser. That needs to be better specified. Managing uploads, and there are a bunch of other stuff that needs more work. So the work of the Chrome team in a nutshell is in Q2, video should hit the developer channel. So you should have video, local storage, app cache, and workers very soon. With some polishing work on all these during Q3. And all this will be available when it says developer channel, that means in the Chromium project. And that's what I'm running here. Actually, that's Google Chrome. But if you go on code.google.com, you can find, there's an open source project called Chromium, and this is where the Chrome development happens. So you can download nightly builds from developer. WebSockets and CSS3 should come in Q4, and then in Q1 there should be other APIs coming in there. A few resources, so the WhatWG group, which defines HTML5, this is where you will find the spec, the Chromium project, O3D project. I have a bunch of demos. When I find a cool demo about Open Web, I tag it on Delicious, so you can find them there. The Canvas tutorial by Mozilla is pretty cool. The Opera blog for that is good as well. The Bspin project. So all these are pretty cool resources. As a conclusion, something I found really very enlightening and talking about Google's effort to push open web standards is Sridhar Vembu's quote that he made a blog post after Google I/O last week. He's the CEO of AdvantNet. These are the people who create the Zoho Office online application. And he wrote a blog post called Microsoft Silverlight versus Google Wave, Why Karma Matters. And essentially in there he argues that Google is driving web standards forward, and himself, who's in a company who's competing with Google for some products, because Zoho is really in competition with Google Apps, he's still interested in web standards because he thinks that we don't abuse our position and we understand good karma of trying to push open standards. So you can learn more at codegoogle.com/chromium for the Chrome project, and at the other resources that I showed before. These slides, I'll push them on SlideShare an hour after this presentation, so if you look for my name, you'd be able to find them. That's it. So thanks very much. Do you have any questions?
感谢 Patrick， 大家有什么问题吗？有什么问题可以提？工作人员，请问有那个麦克给他吗？
Oh.
Hello. I think maybe HTML file has successful and complete industry standard. So, what do you think of collaboration, HTML file and Google such as API in our application development?
Sorry, can you repeat the question?
Okay, I mean HTML file have a successful and formal industry standard. Okay, so what do you think of collaboration between HTML file and Google API in our application development?
So Coco API?
Google
API.
Yeah.
Sorry.
Sorry.
Yeah. Sorry about that. I'm sorry. So the question is collaboration between HTML5 as a standard and Google APIs. So that's a very good question. They are very. We actually consider HTML5 as one of our building blocks for Google applications. You've seen some of the demos in the keynote this morning. They're all built on HTML5, whether it is Wave or Gmail mobile that works offline. So we use HTML5 pretty extensively in Google products, and we've bet on the web development model for building applications. So HTML5 for us is a building block for our technologies, but we consider it's an open standard, and we're really happy to work with the open standard and to help the open standard be adopted. That's why actually we have our team of open web advocacy. Now, how does it work with other Google APIs? Google APIs were designed, whether they are the REST APIs or the AJAX APIs, they're designed to work really well in a web environment. So if you're working at HTML5, if you're building an HTML5 based application, it should be very easy for you to use one of the AJAX APIs or one of the REST APIs on the server side, or OpenSocial if you're building a gadget. All these play really well together. We try to leverage standard as much as possible when we're building APIs.
Thank you.
感谢这位同学提问，还有其他同学？后面一位。
Okay, thank you very much for your presentation, and I'd like to know that could you give us an estimate that when will the HTML5 will come out of the draft to become a real release?
That's a great question. But you should, so the question is, when will HTML5 come out of the draft status? Because yes, HTML5 is a draft specification that's designed by the HTML5 WGG working group. And there are some talks about like going to a full standardization process. It's Ian Hickson at Google who's working on that. And I know he's collaborating with W3C. I think Sam Ruby from IBM has been named chair of the HTML5 working group, looking at making HTML5 a standard, like a real formal W3C standard. I don't know when that will happen. I know there's been lots of discussions in the mailing list, if you're interested in that, where they've been discussing about various dates. I don't remember what Hixie said about the date that he's shooting for. I think it's the next 6 months or something like that.
I think it doesn't matter. Could you just give us an estimate, just a guess?
Oh, that would be tough. That would be tough, but I think the real answer to your question is it doesn't really matter. What matters is that HTML5 made lots of progress in the past few years by being an informal standard where in the WhatWG working group, they are mainly implementers. So Opera is part of that, and Mozilla, and Apple, and Google. And all these implementers work the standard and then implement it immediately in browsers. So the fact that the browsers start to get these capabilities is what is important, not when the spec will be frozen. So the spec has been pretty agile, adding features to it, and you saw there's still lots of stuff to add into it. I'm pretty sure the first version of HTML5 that will be formally ratified as a standard, it should have app cache and offline on workers, and Canvas for sure. For the rest of the feature, I don't really know what they will put in there. So I would say expect in the next 6 to 8 months that there will be some release of a formal HTML5.1 standard or something like that. But for me, the important part is more like looking at compatibility tables like QuirksMode, for example, on quirksmode.org. And Google is funding that effort. You will see some compatibility tables to see exactly for each feature which one is implemented in which versions of browsers. When you're building your application, at the end of the day, that's what counts more than having like a ratified standard with everybody having signed up on this.
Okay, and I've got another question now. There are some features that to be implemented in HTML5, like the P2P features, but some guys said that it is not necessary, and many features of the many planned features of the HTML5 are still in discuss or are still in argument. So what do you think of that? Thank you.
Wow, that's a big question. So if you don't agree with the direction where the WebWG group, where the group is going with HTML5, this is an open discussion, and Jan Hixen is looking at all the arguments and trying to compile them and trying to get... The philosophy here is like the IETF, it's rough consensus and running code. So the best way to orient the standard is just get into your favorite issue, do an implementation in Mozilla or in Chromium, and just argument in the mailing list for your favorite solution.
好的，谢谢。下一个问题，这位前面这位女同学。
Thank you. Hello, Patrick. I have a question. Do you think HTML5 has some conflicts with CSS and XML 1.0? The XHTML and CSS set the design language and some program departed. And HTML is the same as HTML4. It don't set the CSS depart from the HTML. How do you think the conflicts between HTML and XHTML?
Okay. So the question here is about the relationship between XHTML, which was the standard pushed by W3C, and HTML5, which was created by the WebWG working group. So here there's a long and troubled history behind your question. And it goes back to the roots of the WebWG working group. Essentially what happened is it started a few years ago when Jan Hixen was at Opera, and he wanted to push HTML forms, like a new specification for more powerful forms, through W3C as part of the XHTML working group. And the working group kind of told him and his friends who were interested into moving HTML to just go do it somewhere else. And so that's why they created the WebWG working group. That's a very pragmatic group of implementers as opposed to a standard body. And their goal was to make some progress on HTML features to allow developers to create more powerful applications. So it started with Forms 2, and then they started adding Canvas, and then all the other features, video, and all the features we've been talking about. The main success that they had is that because that group was made of implementers, people who write code, they wrote the implementation in the browsers on which they were working for all these features that they were specifying. And so this lasted for a few years, and now we arrive at a point where HTML5 really starts to be a pretty solid spec with pretty good implementations, and that's why W3C is now interested into formalizing a standardization of it. So now, HTML5 versus XHTML, I think Jan Hixen runs some statistics in the Google Index before, like a few years ago, to look at how many XHTML documents there were in the wild. And basically, apart from Sam Ruby's blog, there are not many of them. So XHTML has not really been adopted by developers and people who create web applications. And we hope that HTML5, because it's much easier to adopt, there are no namespaces in there, will be much easier for adoption.
下一个问题，后面的那位男士。
Hi. As you mentioned, the many Google new products are heavily based on the HTML5. But I think many people as me have the worry about what if the Google failed to make it a industry standard? What if, how will Google to handle it?
So is the question, what
Yeah.
will Google do if some of the proposals that we made don't make it into a standard?
Yeah, right, exactly.
I see. So
But
many of the features that are used in Google products today, many features of HTML5, such as offline and the local database, these are already part of the HTML5 working draft. So they are part of the HTML5 working draft, and they are part of the implementations of 33% of the browsers in the market. So that's what counts. At the end of the day, Google is a very pragmatic company. What we're interested in is that our software runs into the maximum number of platforms. And I think today, with all modern browsers implementing that, we have a pretty good shot at starting to use these features in our own products. Whether they get standardized by the W3C or not in the end, what counts is that browser makers implement these features.
好的，谢谢。这边的这位男士。
Well, I have two questions. The first, in some way, HTML5, Flash, and Silverlight are competitive technologies. And do you think who will win the battle in the future? And the second question is, as HTML5 has many new features, it will constrain a lot of memory and computing power. And do you think it is wise to run HTML5 in some embedded devices? Yes, thank you.
Oh, two very good questions. So the first one is HTML5 versus Flash and Silverlight.
Yes.
So at Google, we believe that the web should be open, should be based on open standards, and that's why we're putting our weight behind HTML5. And we're not the only ones. There's Apple that's part of that, Mozilla is part of that, and Opera as well. So we believe that in order to create rich web applications, you shouldn't be obliged to rely on a proprietary technology that's not open like Flash and Silverlight. So we have some good hopes that the web will win in the end. So that's for the first question. The second one...
The second one is, as HTML5 has many new features.
Yes.
And yes.
Oh yeah, so the second one is about the fact that HTML5 requires a lot of processing power for some of these features. Actually, I don't have internet access with my iPhone here, but many of these features are already running in Safari on the iPhone, and it's working pretty well. So sure, the mobile devices will maybe need to implement these features in a power-efficient way. And when you're building your application, you should maybe take a look at the user agent and see if it's mobile, and maybe make a less heavy use. Like for example, maybe that demo with the worker threads where I do movement detection. Maybe this one will tax quite heavily the resources of a cell phone. But still, cell phones are following Moore's law as well. So we believe that they're going to become more and more efficient with time. Thanks. I think the time is out. Thank you very much for coming, and I look forward to see all your applications.
I need to do me a favor. I need to check. I'm requested that everyone shares if you
definitely. I'm going to
look into the call because people
yeah.
rush to me and Rust, you know,